Hi everyone, welcome to this channel. In the previous session, we talked about the introduction to the Internet of Things, and then devices and endpoints of Internet of Things. Now you are going to know about the sensors and connectivity. In this session, you will talk about the what is a sensor, what are the different types of sensor, and then what is a sensor node, what is the difference between the sensor and sensor node, and then what are the different types of sensor nodes available, and then now you will talk about the internet communication. So in the internet communication, which type of protocols you will use, and TCP, UDP, and IP, and then coming to the IP address. What is an IP address? What are the different types of IP address available, and then what is a MAC address, and then what is the difference between IP address and MAC address, and finally you will talk about the TCP and UDP ports, and then application layer protocol. This is a simple concept regarding the unit 3. Thank you. Okay, in the previous session we discussed about the sensors, sensor node, the components of sensor node, different types of sensors, as well as the categories of sensor node. After that, you completed the next task, internet communication. In the internet communication, use the different protocols, TCP, UDP. That means the internet communication among the different IoT devices. How can you establish the communication among the different IoT devices by using different protocols, TCP, UDP, IP, and then HTTP. With the help of this protocol, you establishing the communication. That means, and then TCP, you discussed about the TCP IP reference model also. Now you are going to know about the IP address of the different IoT devices. What is an IP address? Here, then in the computer networks, you already know about the IP address. IP means Internet Protocol. Internet Protocol address here that is assigned to each device connected to the network. For example, 192.168.100.1 is an IP address. Here, the 192.192 is a 1 octet. Here, for this 192, how can you dividing the 192 in a binary format? The octet consists of 8 bits. Each and every octet consists of 8 bits. And then 168 second octet. And then 100 third octet. And then 1. 1 in the sense, the binary representation, I can easily represent the 1. How can you represent 0, 0, 0, 7 zeros and then 1? 8 bits format. That is a fourth octet here. The IP address for assigning the IP address for the each IoT device in a system. That means these IoT device always connected to the network. Each device uses a IP address for communication. Here you are using the different IoT devices. What is the IoT devices here? Each and every device. IoT device in the sense it's having the IP address connected. That means that's having the internet connectivity required. That is the main purpose of IT device. Here in the IoT device uses a IP address for a communication. For, for example, mobile phone uses some IP address, and then washing machine uses some IP address. If it is a smart fan, you also uses some IP address. With that IP address, these devices connected are communicated. Here it behaves like a identifier. This IP address used to identify the device on a network. Here, this particular IP address, I explained 192.168. That is a private networks, and then 1.0.0 like that. These are all our private networks here. And then the IP address defines the technical format of the packet. Here, both the IP and then TCP are combined together. They are referred as a TCP IP. Here, this information creates a virtual connection between a source and destination. Here, coming to the, you can also define the IP address as a numeric address assigned to each and every device. That means you are assigning the numeric address here. If you see here, you have a different smartphone is there, laptop is there, and then computer is there. Like that, different also devices are there. Here you are assigning some IP address for the each and every device. Here an IP address is assigned to each device so that the device on the network can be identified uniquely. Here TCP IP protocol uses a 32-bit address known as a IP version 4. Here you have a two different types of IP addresses are there. One is a IP version 4 as well as the IP version 6. Now you are going to know about the IP version 4. Here what is the IP version 4 here? Here, this particular IP version 4 uses a IP address. IP address format. What is the IP address format here? The format of the IP address appears like this. This is a 192.168.100.1. 168.100.1. In this IP address divided into four octants. Four octants. The first octant having the 8 bits of data, second octant having the, another 8 bits. Like that, you have a 8 bits of data. Here, this is a 32-bit address written in a 4. Okay, good evening. In the previous session, we discussed about the sensors, sensor types, and then types of sensor nodes, and internet communication. You, uh, there you discussed about the TCP, UDP, IP, different DCP IP protocol suite. Here now we are going to know about the IP address. In the previously discussed about the what is IP address and then some information. Here coming to the IP address, it is a in the form of four octets are there for the IP address. It is a internet protocol address. Here each device uses a IP address. If you have the any IoT device that's having the IP address, and then the technical format here IP address defines the technical format of the packets. Here the IP address creates a virtual connection between a source and destination. Here the numerical address, it is a numerical address. You can IP address is assigned to each device so that the device on the network can be identified uniquely. That means you can give a, for each and every device you are given the IP address. And then the very important task, there are two types of IP addresses are there. Here one is a IP version 4. There you will discuss about the domain name system DNS and then IP version 6. Here coming to the IP version 4. Here what is the IP version 4? The IP version 4 is a current version, that means most commonly used IP address. It is a 32-bit address, which is that means four numbers are there. For example, 192.168.1.1. Four numbers are there. Each and every number separated by the dot. Here, this is a unique for each and every device. For example, 166.94.9.22. Here, if the IP protocol knows the address of source and destination. For example, human addresses are some Krishna, Hyderabad, like that. In that particular cases here, the low level computer networking, the low level computer networking will understand zeros and ones. So numbers are much easier to deal with. So IP addresses are numbers. That means always you are using the IP addresses are the numbers. Here the IP address is a 32-bit number. So it allows a 2 power 32 addresses. Here IP, that means number of header fields are 12 and the length of the header field is a 20. Three types of IP addresses are there: unicast, broadcast, multicast style of addresses. Unicast address, the first important one, unicast addressing mode. Here in this mode, data is sent to only one destination. Here in the right side diagram shows the data you will send in a only one destination. The destination address field contains 32-bit IP address of the destination host. Your client sends a data to the server. And then in this case here, packet is addressed to all hosts in a network segment. The destination address field consists of here the broadcast addressing. Here in the broadcast addressing the sense you are sending data to all hosts in a network. For example, the destination address is a 255.255.255.255, and then it's bounds to the process. When the host sees this packet on the network, it bounds to the packet. The client sends a packet which is entertained by the all servers. And then multicast addressing. Here multicast addressing is not a unicast addressing, not a broadcast addressing. Here it's not send data to the single host or not send data to the all host. That means it sends the data to the more than one host. Here in this packet, the destination address consists of a special address which starts with the 244.x.x. and can be entertained by more than one host. And then this is some information regarding the multicast addressing. And then coming to the IP address format. The IP address format always consists of net ID as well as the host ID. Here, the four numbers are called as octants. Each octant consists of 8 bits of numbers. Octant is divided into two components, net ID, host ID. What is a net ID here? Identifying, that means this is used to identifying the network and the particular network. Host ID is used to identifying the host within a particular network. That is a representation of host ID and net ID. And then IP version 4 address classes. We have a 5 different classes are there. The class A, class B, class C, class D, class E. Different classes available. Here, the first class A address. What is a class A address here? The first bit of the first octant is always set to 0. The first bit of first octant, for example, 192 dot. In that 192 dot here, the value set to 0. That means not GLA. That is a representation of binary format. That means always 1 dot, 2 dot, 3 dot, like that. The addresses are appears like this. The class A addresses here always set to 0. If you see here, 1 to 127. In this case here, the first bit of first octant always set to 0. This is the first bit here. You are setting this value as a 0. The first octant range from 1 to 127. In this case, that means IP address starting from 1.x.x.x to 126.x.x.x. Here 127. What about the 127? 127 is a loop MAC address. Here the default subnet for the class A address is a 255.0.0.0. That means addresses can have 226 networks and 2 power 24 minus 2 host. Class B addresses. The first 2 bits of in a first octant set to 10. The first 2 bits. Here in this case, for example, 128 to 192. In this case, it's set to 10. That means the range of this class B address is the first octant here is 128 to 191. The default mask for this one is 255.255.x.x. Here class B has a 2 power 14 network addresses and then 2 power 16 minus 2 host addresses are there. And then class C. Here in the particular class C, the first 3 bits are in a first octant set to 1010. No, 110. That indicates that the range here is a 192 2 to 3 to 23. That means, for example, 110000 6 zeros and 110 5 ones. And then class C IP address range from 192.0.0.x to 223.255.255.x. The default subnet mask here is a 255.255.255.x. Here it's having the same. Similarly, class B having the some network addresses. Similarly, here also having the 2 power 21 address network addresses, 2 power 8 minus 2 host addresses available here. Similarly, class B here the first octet, that means IP address. How can I set the IP address here in the particular first octet? The first 4 bits are set as a 11110. That means the range here is a 224 to 239. Triple one, that means the binary representation here is a triple one 5 zeros minus triple one 0 4 ones. The range here, that means here this indicates the range of the IP address. Here, this particular D reserved for the multicasting. In a multicasting data is not destined for the particular host. That's why there is no need to extract host address from the IP address. So the class D is not have any subnet mask. We are coming to the class E. That means the class is, what about the class E? The class E is reserved for the experimental purposes only, for the R&D and study. Here, the range here is a 240.0.0.0 to 255.255.255.254. Like a class D, this class also equipped with not equipped with the subnet mask. That means it's not having the any subnet mask. Class D not having subnet mask. Here also not having the subnet mask. Here coming to a very important task, the types of IP addresses. Here IP addresses may be the following types: static IP address, dynamic IP address. Here, what is the static IP address here? The static IP address is a IP address that once assigned to network element always remains same. If you assign a static address for the network, it cannot be changed. Here, most probably for the servers you are using the for identifying servers you are using this static address. Here there are that means you will configure this one is a manually. Dynamic address here temporarily assign IP address to the network element. This is called the dynamic address. Here this can be assigned to different devices if it is not in use. The dynamic address assigned by the dynamic host configuration protocol. And then static address assignment. How can you perform the static address assignment? Once your device is assigned a static address, that number stay the same until the device that means destroyed or your network architecture changes. Here if that means that is a case here. The static address generally used by servers or other important equipment. But if it is important equipment, then only you will use the static address. The static address are assigned by the network service providers. Here coming to the dynamic address assignment. That means the assigning, reassigning, and modification of dynamic address is managed by the dynamic host configuration protocol server. One of the reason behind having the dynamic address is the shortage of the IP address on the IP version 4. The dynamic IP addresses allows a single IP address to be shuffled. That means it's between a many different nodes. And then differences between these two. That static address cannot be changed, but here dynamic address can be changed. Here, the most devices use a dynamic IP address, which are assigned by the network when they connect and change over the time. Here, the advantages for the IP version 4. The IP version 4 is security. That means it's having the encryption to keep up the privacy and security. IP version network allows allocation is significant and has a quite 55,000 practical routers. It becomes easy to attach multiple devices that means across the network. And then that this is a model communication. So that provides a quality service and as economical knowledge transfer. That means it's always providing the quality service. That's why most of the devices uses a IP version 4. Routing is a lot of scalable and economical as the result of addressing is a collective more effective. The data communication across the network becomes a lot of specific in a multicast organization. That means it is a some advantages regarding the this IP version 4. That means I have a some drawbacks are there. Why, what are the drawbacks here? The population. Here the population of the world here is a 700 crores. Here, that means every user uses a more than one device. For example, one person I am using the more than one that means one laptop, one mobile phone, like that different devices you are using more than one device connected with the internet. The, that means the private companies depends upon the internet. Here, as you know, that's why that means IP addresses provides a only 400 crores of addresses here, which are not enough for each device connected to the internet on the planet. So there is a another alternative solution is there that's called here. That means not only that information here. Here, these techniques, public IP is converted into private IP, due to which the user having the public IP can also use the internet. Here, because of these reasons here, this was not sufficient. So, it gave a rise to development of next generation of IP address. Here, what is the next generation of IP address here? IP version 6. IP version 6 having the 2 power 128 addresses are there. 2 power 128 addresses means that means 2 power 32 means 400 crores, but the 2 power 128 you cannot predict that value. That's why you have a these number of addresses. That's why you enter into the IP version 6. Here you have a some special addresses for the IP version 4. What are the special addresses here? 192.168.0.0 used for a local communication within a private network. And then 8.8.8.x address of several IP ranges assigned to the Google. Here 192.168.x.x. That means it is a assigned for the private networks. That means private networks in the sense your home or your office network. That means anything here, your office network router may well assign IP address in the range 10.x.x.x, a private range here, that one also. Another private range. For example, here 8.8.8, the address of a Google, that means address of one of a Google's domain name system server, DNS server. Here next you will discuss about the DNS server. Here why? Because the, what is the specialty of DNS server? That means IP address is the numbers. That means the human person that means recognizing. That means remembering those numbers very difficult. For example, if I want to open the any website here, I need to remember the 192.168.1.1. But that's very difficult to remember. Instead of remembering that one, for example, instead of Google 8.8.8, you are using the Google www.google.com. That means letters are there. For that conversion, you are using a DNS server. Next, you will discuss about the DNS server. These are all some references for this one. Here, what is a DNS server? Domain name system or domain name service. Here domain name system or domain name service server. Here what is this one here? This is a application layer protocol. Here there is a host name, domain name server, and then IP address. host name is converted into IP address here. Here it is application layer protocol. DNS is a host name to IP address translation service. Here, for example, I am giving the www.google.com. That google.com can you transform into IP address by using this DNS service. Here, in this case, it converts the names you type in your web browser address, for example, www.google.com, to IP addresses 8.8. Let us assume, not the exact that one. I am telling you, assume. For example, any that means you are typing in a web browser any website that converted into numbers. Here, for converting that website into numbers, you are using a domain name system. Here, posting this site. That means the need of the domain name service arises due to the following: IP addresses are not static, may change dynamically. So, a mapping is required which maps the domain name to IP address of the web servers. Here, IP addresses are complex series numbers. And then here, what is the thing here? So, it is very difficult to remember IP addresses directly. That means very difficult to. That means I am remembering now 192.1. After 2 days, very difficult to remembering the number. Why it is easy to remember the names of particular. That means the DNS allows the names. Here DNS resolution. Here what is a DNS resolution? The DNS resolution is a process of resolving a domain name onto an IP address. Here domain name, that means the converting the domain name. For example, www.google.com into process here resolving. For example, user request www.google.com. Here in the diagram shows that user request, user program request. After that, resolver is there. He is doing something. After that, there is a DNS server is there, and then there is a cache memory is there. Here, user program in this case sends a name query, name in the sense www.google.com. No query to the library procedure, call it as a resolver. Library procedure here in this call it as a resolver. What is a resolver? Resolver look up the local domain name, cache for the match. That means verifying the that name matching in a cache. If it is a found, then it sends a corresponding IP address back. Is it clear? That means your program sends a www.google.com. The resolver identify the matching IP address. If it is a match, here that IP address corresponding to the that IP address back. If no match found, it sends a query to the local DNS server. Here now the DNS server part. It sends a query request to the DNS server. Here coming to the DNS server. The DNS server looks the names. In the server, you will available in the different names. If match is found, here in the DNS server, match is found. It returns the corresponding IP address to the resolver. It returns the corresponding IP address to the resolver. If it is there is a match in a DNS server. If there is a no match in a DNS server, it's not send anything. If no match found, the local DNS server sends a query to the highest level DNS server. Again, there is another level DNS server. This process is continued until the result is returned. Here, that is a DNS server resolution. That means the user program sends a google.com. For google.com, it will verify here catch. The catch, there is a match is there. If it is a match is there, directly sends a user program. If there is no match, then it requires the DNS server. DNS server also do the same thing. What is the thing here? It will, that means identifying the match of the google.com. If it is a match is there, then it sends a reply to the resolver. If there is no match, then no match. What it says? Higher level DNS server, next higher level DNS server. This process continue until the result return. until result return. After receiving the response, the DNS client returns the resolution result to the application. Here, the converting that is a simple information about the DNS resolver. Here coming to the DNS overhead. Here, what is a DNS overhead here? Converting the domain name into IP address is a extra overhead. That means somewhat task. If you type the directory 192.168.1.1, no need work of a resolver, no need work of a DNS server. That means directly you will get. But here you are typing the www.google.com. Then there is some extra burden is there. This burden you call it as a DNS overhead or extra overhead. This overhead you call it as a DNS overhead. Here it causes an unnecessary delay in serving the request. So there is more delay for the first time. Here there is a more delay for the first time, and then to reduce the delay next time, IP address are stored in a computer using a logs. Here that means by taking different logs here, you are avoiding the reduction. This avoids the DNS overhead next time. Take a less time in serving the request. When it gets expired, the request is again served through by using DNS. Here, these are all references for this DNS server. Ma, thank you. Okay, good afternoon. In the previous session, you completed the different tasks: sensor types, sensor node, and then category of sensor, and then internet communication. In the internet communication, we discussed about the IP, TCP, UDP, and then TCP IP is a protocol stack. That means we discussed the concept. And then coming to the IP. In the previous session, we discussed about the what is an IP, what is an IP address, and then what are the different types of IP address, and then the IP version 4 as well as the DNS. We discussed that concept. Now you are going to know about that means previously we discussed the IP version 4. Now we are going to know about the IP version 6. Here, what is a IP version 6? Internet Protocol version 6. That is also called as a IP version 6. Here, the IP version 6 is a successor of IP version 4. Why it is successor of IP version 4? The total range of the IP version 4 is a 4.3 billion. 4.3 billion addresses are there. Here, in the right side diagram shows that the 4 billion addresses are there. That means the IP version 4 has some drawbacks. Why? Because in the world population is a 700, more than 700 crores of people. That means you are using 4 billion networks in the sense, that means IP address in the sense. Why? Because every person having a more than one device in their hand. That's why it is a some drawbacks are there, and then that's why by eliminating that one, the IP introduced the IP version 6. Here this particular IP version 6, 128 bits each. That means range of this one is unlimited. Here 2 power 28 addresses are there. It's having the 2 power 28 addresses are there, and then the IP version 6 developed by the Internet Engineering Task Force to deal with the long and anticipated problem of the IP version 4 exasperation. Here, IP version 6 uses a 128-bit address. That means 2 power 28 addresses are there for the IP version 6. And then IP version 6 is a next generation of IP address. Your next generation. Now you are using for the each and every system IP version 4. The main difference between the IP version 4 and IP version 6 is the address size of the IP addresses. The IP version 6 provides a large address space. It contains a simple address compared to the IP version 4. That means in the diagram here, it's having a large addresses are there. Here, that means you are representing the addresses in this way. You are coming to the difference between a IP version 4 and IP version 6 is the address size of the IP addresses. Here, see here, the addresses. Here, the IP version 6 having the 2 power 128 addresses. IP version 4 having the 2 power 32 addresses are there. That means 4 bytes. Here, coming to the IP version 4 is a IP version 6 provides a large address space and it contains simple header compared to the IP version 4. And then IP version 6 use column decimal representation. For example, in the right side diagram shows some A dot, B dot, C dot, like that dots are there. Here divided into 8 groups. Here the first 3 groups are called as a prefixes, and then fourth group you represented as a subnet ID, and then remaining last 4 groups are called as a interface ID. That means in the IP version 6 divided into how many groups here? 8 groups. A dot, B dot, C dot, D dot, H dot. That means up to H. 8 groups are there. Each group represented 2 bytes. For example, I am taking the X is a one group. In particular group, here you have a 2 bytes here. That means how can you represent, for example, 200F, 200F. That means first 2 bytes, that means one information represented in a 1 byte. For example, that is a each and every group represented as a 2 bytes, 206, and then 001, and then 3239. Like that, you have a different groups are there. Here, coming to the address structure of a IP version 6. The address structure is a 128 bits are there. These 128 bits divided into 8 16 bits block. Here 16 bits block, one block consists of 16 bit. Each block is then converted into 4 digit, 4 digit. For example, 2020 is a 4 digit number. 4 digit hexadecimal number. That means you will use a decimal, hexadecimal number. What is the range of hexadecimal number? Can you tell me? The range of hexadecimal number 0 to F, 0 to 9. After that A, B, C, D, E, F. Up to F, you will use a different number separated by the colon. That means for each and every one, you are using a colon. And then, for example, 128 bits are there. The representation for the binary format, this one. Here, the each and every block consists of 16 bits. Here, the first one X, the second one X, third one X. That means it consists of 16 bits of block. Here, totally you have a 8 groups are there. Each and every group represented as a this 16-bit block, and then each block is converted into hexadecimal number separated by the colon. For example, 4525 is a one group, 0000 one group, 3238 one group. Like that, you are representing the this 6 IP version 4 number like this. Even after converting into hexadecimal format, IP version 6 addresses remains long. Here, this is a, that means it is a very long here. You will see here, for example, 192.168.1.1. It is a very difficult to remember. But if you see the IP version 6, very difficult to remember. Why? Because 8 groups. If it is a very difficult to remember 4 group in the sense, here the IP version 6 is a 8 group. That means it is a very difficult to remember. That's why you have a some rules are laid. That means some rules for shorten the addresses. That means in order to reducing the size of the address, you are using a different rules. What are the different rules here? The first rule here is a discard the leading zeros. For example, if you see the block 5, See here, the block 5 consists of 0063. The block 5 consists of 0063. That means it is having the leading zeros. It is having the leading zero. The leading zeros can be omitted. For example, that value represented as a like this. Here 4525. Here 0063. The 0063 represented as a only 63. If you have the leading zeros, you should remove the leading zero for the block or group. You should remove the leading zero for the group. That is a one rule. And then second important rule here is a if two of more blocks contain consecutive zeros. That means two or more blocks. For example, not a single block here. Two or more blocks contain consecutive zero. Omit them. That means all and replace with the double colon. Double colon appears like this. The double colon, not a single colon here. Here, see here. If you see this diagram here, the sixth and seventh group consists of all zeros. Continuous zeros are there. The continuous zeros in the sense you have to omit these continuous zero in place of single colon. I am using the double colon. That means double colon. If you are writing double colon means there is a leading zero. That means not a leading zeros. Two or more blocks consist of consecutive zeros. That's why you are going to omitting that zeros. That indicates this one. This is a one of the valid IP address of IP version 6. And then the consecutive blocks of zeros can be replaced by once by the colon colon double colon. So there are still blocks of zeros are there in the addresses. Here, if you see here, the address consists of second block. The second group consists of 0000. Four zeros are there. These are all not consecutive block zeros. Here only one block consists of 0000. Here what is the thing here? Omit these 00 and replace with single zero. Here I am replacing with single zero. That indicates that what is the indication here? I am replacing the single zero. That means they're having the block of four zeros are there. The four zeros are replaced with the single zero. That's why you are reducing the size of the IP version 6. In this way, you may reducing the size, even though it is a very difficult to remember. That's why you may take the DNS, a domain name system, converting the some names into IP addresses. For the that means previously discussed that concept domain name system. Here also you will use the domain name system. And then the next important one is a transition strategies. The IP version 6 provides a transition strategies that converts the IP version 4 into IP version 6. Here there is a IP version 4 is there, IP version 6. In order to converting the IP version 4 into IP version 6, this IP version 6 IP address provides a some of the strategies. Here what are the strategies? Here the strategies all follow. The strategies are dual stacking, and then tunneling, and then the network address translation. Dual stacking, tunneling, network address translation. Coming to the dual stacking. Here right side diagram indicates that IP version 6 application. Here there is a IP version 4 as well as the IP version 6 existed in a one system. Here it is a IP version 4 stacking, this one. Here the left side diagram shows the IP version 4 stacking. Like that you are stacking. Here, for example, Ethernet existed in a link layer. IP version 4 existed in a internet layer, and then TCP and UDP existed in a transport layer. Coming to the IP version 4 application. Here IP version 6 layer. Here in the link layer there is Ethernet is there, and then here you are using the IP version 4 as well as the IP version 6 in a single system That is called here dual stacking. Here, what is the dual stacking? The dual stacking allows us to have a both versions, IP version 4 and IP version 6 on the same device. Here, you are giving the IP version 4 and IP version 6 in a same device. That's called here dual stacking. Here, coming to the tunneling. Here, what is the tunneling here? In this approach, all users have IP version 6 communicates with the IP version 4 network to reach the IP version 6. Here, for reaching the IP version 6, you are using this one. And then network address translation. Here, the translation allows the communication between the host and having the different versions of IP. Here, different versions of IP is there. The host system always communication between a different version. That's called here address translation. The network address translation. Here coming to the IP version 6 packet header. A simple header is there. It consists of the portion with minimum functionality required for all packets here. Here may be followed by the optional extension to implement the special features. It is having the version, traffic classes, and then flow label, and then payload length, next header, and then port limit, and then source and destination IP address. The next header is a one of the important one, and then it is having the fixed. This header occupies the first 40 octants. That is called here 320 bits of the IP version packets. It consists of source and destination addresses, the traffic classes, classification. It is an optional one. Hop counter. This one also an optional one. And then type of the optional extension. The type of the optional extension and payload. Payload is very important, which follows the header. These are all components of header. Here, how to interpret this one? If the packet consists of options, this field contains the option type and the next option. The next header is a one of the field. The next header field of the last option point to the upper layer protocol that is carried out in a protocol data. That is called carried out in a protocol data, and then it consists of. That means these are all different information. Here, in this way, in this IP version 6 also, you will use a domain name system. In the previous section, you discussed about the domain name system. Here, what is a domain name system here? The host names are mapped to the IP addresses by triple A. That means A is a quad A. Resource records. Here, that means in order to converting the host names into IP addresses, for doing that one, for reverse resolution, IETF reserved the domain IP of version 6 .arpm, where the namespace is hierarchical divided by the one-digit hexa number representation of nibble unit. Here that is called here represented by the RFC 3596. Here you will that is a representation of IP version 6. Here coming to the different differences between IP version 4 and IP. Very important one. This one. IP version 4 is a 32-bit address. Here the address length. If you consider the address length, IP version bit is a 32-bit addresses. That means that consists of 2 power 32-bit addresses. Here IP version 6 is a 192-bit 128-bit address that consists of 2 power 128 addresses. If you comes to the fields, how can you represent the field? The field is represented by here is a dotted. Here in the IP version 6 represented by the colon, 2 dots, and then classes. Here the IP version 4 divided into 5 classes, A, B, C, D, E, and then IP version 6 does not contain classes of IP addresses, not having any classes. Why? Because 2 power 128 bit addresses are there. It is very difficult to divide in the classes. And then number of IP addresses here. Here number of IP versions has a limited number of IP addresses. IP version 6 have the large number of IP addresses. The 2 power 32 addresses are there here. Here 2 power 128 addresses are there. Here virtual length subnet mask. Virtual length subnet mask support. Here, the IP version 4 supports a VLSM. IP version 6 not supporting the VLSM. Address configuration. Here, that means manual and dynamic host configuration protocol is used to configure the addresses. Here also supports the manual DHCP and auto configuration and re-numbering also supported by the IP version 6. And then that means address spaces are there. 4 billion address spaces are there. And then 340 and display, I don't know exactly that value. And then end-to-end connection integrity. Here, what is an end-to-end connection integrity? IP version 4 end-to-end connection integrity is unreachable. That means the addresses in this case 2 power 128 in a IP version 6. In case of IP version 6, end-to-end connection integrity is achievable. And then security features are there. What are the security features here? It depends upon a application. The address not depends upon a developed in keeping the security feature in mind. IP version 6 having the IPsEC is a developed for the security purposes. Here address representation, here it is a decimal, it is a hexadecimal. IP version 4 is a decimal representation. IP version 6 is a hexadecimal. The fragmentation done by the router in a IP version 6. Here the fragmentation is done by the sender in a IP version 6. Here packet flow identification. It does not provide any mechanism for the packet flow identification, but it uses a flow label field in the header for the packet flow identification. And then there is a checksum field in a IP version 4. In the IP version 6, not a checksum field. And then the transmission scheme. IP version 4 is a broadcasting. Here IP version 6 is a multicasting. It provides a different network operation. And that means IP version 4 supports a unicasting, broadcasting, multicasting also. Encryption and authentication. It does not provide say encryption and authentication, but here it provides a encryption. The number of octants here is a 4 octants. Here the consist of 8 fields, that means 8 groups. Each group contain the 2 octants. This is a some of the references for the this one. Okay, ma. Thank you.
Okay, good morning. In the previous session, you completed the sensor types, and then sensor node, categories of sensor nodes, and then coming to the internet communication. In the internet communication, you discussed about the what is the internet protocol, what is TCP, what is a UDP, and then coming to the that means converting the domain names to IP address, you will use a domain name system or service DNS. And then I'm coming to the next important task, IP address. Here IP addresses differ and IP version 4 and IP version 4.6 you discussed. Now you are going to know about the MAC address. What is a MAC address? And then what is the need of MAC address? Here, in order to communicating or transfer data from one computer to another computer, you need some address. Here, for example, IP address is a one type of address here. That means that is enough. But what is the need of MAC address? Here, in a compute network, various types of addresses are introduced. Here, each works with a different layer. IP address that means network layer. And coming to the MAC, media access control address. Here it is a physical address here which works at data link layer. IP address works with the network layer. Here whereas MAC address works with the physical layer which works with the data link layer. That means in this case combined physical layer data link layer in the IoT system, you combine the both layers, physical layer as well as the data link layer as we call it as a link layer, simply call it as a link layer. Here you will identify the MAC address at the link layer. Here, what is the MAC address here? IP address is a logical address, whereas MAC address is a media access control address is a physical address. That is important point you should know. Here, MAC address is a logic. MAC address is a physical address. Here, it is a physical address which works at a data link layer. And then here, if you see the diagram here, you have a 6 digits are there. Here, these 6 digits represents a MAC address. Here, if you buy any item, if you buy the mobile phone, here for the mobile phone, you have a MAC address is there. That means at the time of manufacturing the product, the company will give a one address. That address we call it as a media access control address here. Here, this address is divided into two parts. One is a organizationally unique identifier. Next one is a network interface controller specific. Two parts are there. The yellow shade indicates that the organizationally unique identifier, and then the network interface controller specific. Here two parts. Here each and every part you can have a, here it is a 8 bits number, after that 8 bits number, 8 bits number, totally 3 8s, 24 bits information is there. Here is 24, totally 48 bits. The MAC address consists of 48 bits. The MAC stands for Media Access Control Address. Here it is a hardware identification number. IP address is a logical number. Here it is a hardware identification number that identifies the each device connected to the network. Here whatever may be the device which is connected to the network, that is represented as a this MAC address. If you see here, this is a, for example, any item. If you buy the any item, you will identify the LAN MAC address. Here, this is a serial number MAC address. Here, the serial number is appear here. WAN MAC address here. That means any manufacturing product here, that product consists of one address that is called here MAC address. Here, MAC address is embedded into network interface card (NIC) in your computer, such as Ethernet card or Wi-Fi card, at the time of manufacturing by the vendor. So it cannot be changed. Once if you fix the MAC address, it cannot be changed. So it is a hardware number of a computer, which is also known as a physical address. That means it is a hardware network address. So hardware address of the network device. Here, for example, in the right side diagram indicates the MAC address, the default IP address. This is the default IP address. It indicates a LAN MAC address and then WAN MAC address. Here, the network interface card is a computer circuit. The computer circuit card that enables your computer to connect to the network. Here, this particular NIC is a computer circuit card. Here in this right side diagram indicates. Here, what about this information? NIC converts the data into electrical signal. Any data, the data converted into a electrical signal that can be transmitted over the network. Here you are sending some data, any kind of data, that kind of data converting electrical signal, you are using this NIC card. And then if you see this diagram, very important one, here how can you frame the MAC address? Here, so in the network along with the IP address, there is a hardware address is there. IP addresses are related to TCP IP, whereas MAC addresses are associated with the hardware of the network adapter. So this network is a physical layer, the physical layer address. So MAC is a computer unique address. Unique address or computer unique hardware number or unique identifier for the Ethernet or network adapter for the over the network. It is a unique identifier. Simply call it as a computer's unique hardware number, or you simply call it as a unique identifier or computer's unique identifier for the Ethernet or the unique identifier for the network adapter over the network. So it is a this is a something about the MAC address in a computer. In the, for that means along with the IP address at the time of manufacturing, along with the IP address, you have a one address is there, that is a hardware address. That address you call it as a MAC address. Here there are plenty of networkable devices are there. Each device required a unique MAC address, so there must be a many addresses required. Accordingly, the MAC address consists of 6-digit hexadecimal number separated by column. That not necessary. That means some persons uses a hyphen, some persons uses a dot, some persons uses a column here. Here, the MAC address always consists of 6 digits number. 6 digits here, one digit number, some that means hexadecimal numbers are there. For example, 0a, 03, b6, 8d, 85, c3, these are all some of the numbers here. For example, B2 FC 36 hyphen B9 hyphen 88 E3. For example, this is my computer MAC address. Here, how can you? That means you will easily identify the computer MAC address. So it is a 12-digit hexadecimal number, which is a 6 bytes binary number and is represented by the colon information. Here, this is that means the MAC address is simply represented in this way. That means 6-digit number. This is a unique number. Here, coming to the first 6 digits. Here, if you see here, the how many digits are there? The first 6 digits. These are all first 6 digits. The next 6 digits divided into two parts. Already explained that one. What is organizationally part? First 6 digits one part, the next 6 digits represent another part. The first 6 digits of MAC addresses provides a information about the manufacturer. It is a organizational unique identifier. Here, coming to the next 6 digits, in the 12 digits, the next 6 digits indicates that here the network interface controller, identify the network interface controller, which is assigned by the manufacturer. Here, that means its MAC address, first 6 digits provides a MAC address information about the manufacturer. That means the organizational unique identifier. The next 6 digits identify the network interface controller, which is assigned by the manufacturer. The network automatically recognizes this number. Automatically, if you connect with the network here, automatically recognize this number. You don't need to remember this address. Here, IEEE Registration Authority Committee assigns the MAC prefixes to its registered vendor. That means this is a simple address. With this address, you can easily identify the information. The MAC address are unique. Already discussed. 48 bits are there. The first, that means each and every digit is represented as 8 bits. 888. That means totally 48 bits are there, which is embedded into network card. Already you know that one. The network interface card during the time of manufacturing. The MAC address is a physical address. That means IP address is a logical address. Here IEEE 802 standard. The data linker is divided into two sublayers here. What are the two sublayers here? The logical link control sublayer, the MAC media access control sublayer. Two sublayers are there. In this two sublayer, MAC address is issued by the media access control sublayer. The MAC address always, this is a divided into 6 octants. In the each and every two numbers you are using, each and every octant. Here first 3 octants are represented, already discussed. Organizationally unique identifier. The next 3 octants are represented as a network interface controller specific. That means we discussed that one here. Here, for example, these are all representation of this information. Here, that is a unicast, multicast. Here, The MAC address is a worldwide unique number. Since millions of network devices existed and you need to identify this address. Here format of this one, already discussed that one. Here, for example, there is a specific MAC addresses are there. The Cisco company. Here, that means the first, not the first three digits. The next three digits, first three digits are organizational unique identifier. Here, these are all the Cisco, Google, and then HP, Hewlett Packard, and then Huawei Technologies. These are all organizational unique identifier. These are all MAC address. That means first six digits are appears like this for the Google, and then the right side, rightmost six digits. The rightmost 60 digits are represent a network interface controller. The next six digits, which are assigned by the manufacturer. That means already discussed that concept here. The MAC address is represented as a column notation, but it's not a necessary, not a mandatory here, but this is just a conversion, not a mandatory. The MAC address can be represented using any one of the right side following format. Here in the first diagram indicates that hyphen hexa notation, and then colon hexa notation. Here period hexa notation. That means you may consider any one of the following format. That means not necessary you should use colon format. Any one of the any one of the format for the MAC address. And then how to find out the MAC address? Very important one. How to find out the MAC address is here. Here, for example, there is a open the Linux terminal. In the Linux terminal, type this one, ify configure. Then you will identify the easily the MAC address of your computer. Here, for example, I am using the Windows operating system. Okay, let us try. Let us try that one. Here is there if it is execute or not. Here I am trying that one. Okay, here you will identify the command from. Here, if it is a Windows operating system, you type this one, ify configure /all. Then it will identify your IP address, your MAC address as well as your IP address also available for this one. That is a important thing. And then here, for example, Mac OS. For the Mac OS, you will type like this: TCP/IP control panel. This is in this way you will identify your MAC address. And then coming to the types of MAC addresses are there: unicast address, multicast address, broadcast address. Unicast address in the sense already discussed that concept unicast. Well, for example, transferring the only single computer. Here broadcast in the sense all computers. Multicast in the sense not limited to single person or all. That is a multicast and then broadcast. Unicast address. Here, what is a unicast here? The unicast address frame is a only sent out to the interface leading to a specific NIC. Here, it's a specific NIC. It is sending the data. If the least significant bit of first octet of the address is set to 0, the frame is meant to reach only one receiving NIC. The MAC address of a source machine is always unicast. That is a simple information about the unicast addressing. Here, the next important one, multicast addressing. The multicast addressing in the sense allow the source to send a frame to the group of devices, not for the single device, not for the all devices. Here, if you see here, in the previously it sends to only one device. Message here. See here, the message it sends to only one device. Here, if you see here, group of devices sends at a time. Here, that is a multicast. The multi in the right side diagram, 3 devices. It sends a information to the 3 devices. The multicast address allows the source to send a frame. Frame in the sense it simply called it as a packet or message frame to group of devices. Here in the layer 2 Ethernet multicast addressing, least significant bits of the first octet of address is set to 1. Okay, IEEE has allocated the address block like this. Here for the group addresses, your addresses like this 01, 022, these addresses are there 01, 08, C2, 00002, 01, 08, C2, FF hyphen FF hyphen AFF for the group address for use by the standard protocol. That means these are all some of the information regarding the, that means IEEE allocates a block address in this case. This is a multi-class addressing. Here broadcast and the address in the sense sends a packet to all source, all destination. Here it is similar to the network layer. The broadcast also possible underlying layer data link layer. Here Ethernet frame with ones in all bits of a destination addresses are referred as a ones to all. That means in the right side diagram indicates that it's the packet will reach to all addresses of a packet. The frame which are destined with the MAC address will reach to every computer belongs to that LAN segment. This is a broadcast addressing. That means unique cast in the sense sends to the only one source to one destination. Broadcast in the sense all destinations you are sending data to at a time, and then multicasting in the sense not a single one, not all one, neither the single nor all. That is a multicast addressing. That is a, so that means ISP use the MAC address in order to assign a IP address to gateway devices. Here in this case, when a device connects to the ISP, the dynamic host control protocol server records the MAC address and then assign a IP address. That means this dynamic address assigned by the DHCP. Here now the system will be identified by using MAC address. When the device gets disconnected, it loses the IP address but not MAC address. Here that is it. If user wants to reconnect, the dynamic host control protocol server checks if the device is connected before. If so, then the server try to assign a IP address in case the lease period not expired. Here in the case user change the router, the user has to inform the internet service provider, ISP, internet service provider, about the new MAC address. Become the new MAC address is unknown to ISP, so the connection cannot be established. That is a thing. Or if there is another option is there, if other option is cloning, the user can simply clone the registered MAC address with the ISP. Now the router keeps the reporting old MAC address to the ISP and there will be no connection issue. That is a simple information regarding the MAC address. If you need a references, see the references. These are all some of the references for the, that means Wikipedia. You may follow these references. Okay, ma'am. Open the command prompt. Type here IP configure all. Then you will identify this information, the MAC address, the physical address. Here you will identify 28-C6-3F. Open this one, maximize this one, 3F 28C6-3F DC, and then 2B448. Here this is a MAC address, the physical address of your system. Here not only that information, and you have some other information also existed here. Here what is the information? The Windows IP configuration, the host name, this one, the IP routing enable, and then wireless adapter information. That is a physical address information. After that, there is a physical address information for this one, media disconnect information. LAN adapter. For the LAN adapter, you have a this is a physical address. For each and every information, we have a physical address is there. This is a MAC address or this address. I think is it clear? Okay, ma'am. Thank you. Okay, good morning. In the previous session, you completed the sensors, different types of sensors, and then sensor node, the categories of sensor, and then internet communication, after IP address and MAC address. You completed all these tasks. Now you are going to know about the TCP and UDP ports of a IoT system. Here, what is the port exactly here? The port is a communication endpoint here. Sometimes 192.168.2.80. What about the 80? 80 is a port number. That means the port here is a port. It may be a TCP port. It may be sometimes it may be IP port. The client along with the client IP address, not a client, it's a server IP address. You are having a some port number. There is a necessity. The port number always showing that the process, the service information. It shows the service number. That means the computer having the different services are there, different processors, a n number of processors running in a computer. That means I want to identify the particular process by using this port number. Here, for example, in this diagram here, you are having the port number 5000 and then port number 8 is there. For the client IP address 1.1.1.1, for server IP address 1.1.1. Along with this IP address, you know very well about the IP address. IP address is a logical address. That means logical address. Along with IP address, you are using the port number as a service number or process number. And then at software level, within an operating system, port is a logical construct that identify the specific process or type of network service. Here, in order to identify in the specific process, you have a use a one logic construct. The particular logic construct, you call it as a port number. Here, in this case, the 500 is used for some special purpose. 80 also used for some special purpose. That means you have a the numbers is the port number is a 16-bit unsigned number. For example, 001 number, 011 number, 021 number, 10. That means each and every, this is called here 16-bit unsigned integer number. Here the range here 0 to 65,535. That means the ranges from the 65,000 to 535 you are using as a port number. That means in these much number port numbers are there. Some of them are well-known port number, some of them are service port number. Like that, different port numbers are there. That is a port number. That means there are different for each port number have the different services. That means it is used to identifying the specific process. And then port number always associated with the IP address, the IP address of a host. For example, you have an IP address like this 192.0.2.5, 192.0.2.6. Along with this IP address, you have a port number. Here, port number always associated with the IP address of the host. That means and the type of the transport protocol used for the communication. Which type of protocol used for the communication? And then specific port numbers are the reserved to identify as specific services. Here there is a reserved port numbers are there so that an arriving packet can easily forwarded to running application. Here we have a different port numbers are there. Among the port number, the specific port number is used for the specific purposes. And then you have a different port numbers are there. Here, for example, for this purpose, the lowest number G1024 port number. Here, identify the historical most commonly used service and are well. That means these are all lowest numbers here. If you see here, 0 to 123 up to 123 well-known port numbers. Here, Commonly service port numbers here. So totally you have a 1024 port numbers are there. The range from the 0 to 10 1023. The totally you have a 10 is one port number. 1024 port number also called it as a well-known port numbers. 1024 also 242 149,151 registered port number. 49 152 to 65,535 dynamic port number. These are all called as a different port numbers category as well as their ranges. And then higher number port numbers are available for the general use by application and are known ephemeral port numbers. And then coming to the port provides a multiplexing service. Multiplexing service in the sense several services combined into as a single service. That means multiplexing service. That means you have a in this diagram here there have a services A B C D E services are there. Here combined into single service that's called here multiplexing. That means multiplexing service. There are the multiple communication sessions at one network address. Multiple communication sessions are there here. That is a multiplexing service. Several port numbers you are using for providing the multiplexing service. In the client server model, the application architecture, multiple simultaneous communication sessions may be initiated for the same service. And then you have a port is identified for each transport protocol. For each every transport protocol you have to identify the port and address communication by 16-bit unsigned number is called as a port number. Here for example in this diagram here you have a specific transport protocols UDP protocol that means associated with the these services. That means THC services 67 137 and then 53 DNS services and then 123 and that means SNTP services. Here for this providing these services the port number is identified for each in the transport layer you have a different port numbers are there for the UDP port number and then address communication by 16-bit unsigned in number also known as a port number. And then most common transport protocol that use the port numbers are these are all most common port numbers. What are the port numbers here? TCP port and then UDP port. Transmission control protocol port, first one. Here these are all transmission control protocol port numbers 23, 25, 21, 80 and then UDP port numbers. UDP port number 67. Let us simple example. Let us simple examples of different port numbers. And then the TCP port number. The TCP port number coming to the first important one TCP port number. The TCP port number is a unique number assigned to different applications. Here, for example, we have opened the email and the game application in our computer, and then using email application you want to send a mail to the host. By using game application you want to send a some play the online games. Like that, you have to send these information. That means each and everyone is a service. Here, how can you represent these services here by using these port numbers? And then coming to the in case of TCP, zero port number is reserved and cannot be used. Here zero, that means 0 to 1023 is a well-known port numbers. Here in this case here zero port number is a reserved but it cannot be used. And then whereas UDP port number zero port number is not available. Here that means Internet Assigned Numbers Authority is a standard body that assigns a port numbers. Here there is a IANA. IANA is a standard body that assigns always assign the port number. For example, port number, for example, 192.168.15.60 colon 80. In this case, 192.168.15.60 is a IP address. IP address is a logical address. Yeah, that means which and every system identified by using this IP address. What about the 80 here? Here, in order to identifying the in the particular system, particular process by using this 80. Here 80 is a port number in this case. In the above case here 192.168 is a IP address and the 80 is a port number identifying the service. Identifying the system by using IP address, identifying the service by using port number. To access a particular service, the port number used with the IP address. Here, if you want to access in the particular service, I want to access the HTTP service, I want to access the DNS service, I want to access the FTP service. Here, if you want to access those services by using port numbers, and then the port numbers ranges are here 0 to 123. 0 to 1023 is reserved for the standard protocols, and the other port numbers are user defined. And then what is the need of port numbers here? What is the need of port number? A single can have the multiple connections with a same server and or multiple servers. For example, I am using this system. I am connecting with the multiple servers. I am going to connecting with the Google server. At the same time, I am going to connect with the Microsoft server. At the same time, I am going to connect with the freshersworld.com server. That means whatever may be the server here, that means same time I am going to connecting the multiple servers within a same server. That means the client may running the multiple application at the same time. That means I should run the multiple application at a time. Here, for this purpose, when the client tries to access some service, then IP address is not sufficient to access these services. That means by using IP address is not sufficient to access the all these services. For doing that one here, to access the service from the server, the port number is required. That means you require the port number to access those services from the server. For example, 192.168.2.3.80. Here in this case, so the transport layer play a major role in providing the multiple communication between these application by assigning the port number to the application. Here, different applications here. The major role in the transport layer here is providing the multiple communication. Providing the multiple communication between these applications. For example, the classification of port numbers. Here, how can you divide? You will divide in the port numbers into three classifications. One is a well-known port number. The right side diagram shows that well-known port number, a registered port number, dynamic port number. Here, these are all are the different port number. The well-known port numbers are range from 0 to 1023. The registered port number 0 to 10242 to 49,151. And then the next dynamic port numbers are range from 49,152 to 65,535. Here coming to the first one, well-known port number. What is a well-known port number? You know the range of the well-known port number 0 to 1023. And then well-known port numbers are used with these protocols. Here, what are the protocols here? These are all some of the protocols here. That means already you know very well about the well-known port numbers. We use it with these protocols that serve common application and services. Here, that means always works for these well-known port number. 1024 different port numbers are there. With these all port numbers works with these services. What are the services here? The services here is the HTTP service. Previously discussed about HTTP, hypertext transfer protocol, and then internet message access protocol, simple mail transfer protocol. With these protocols, you will access the services. And then coming to the, for example, you want to visit the website on the internet, use HTTP protocol. The first service here is a hypertext transfer protocol. Hypertext transfer protocol. Here, if you want to visit the website, how can you visit the website here? For example, http://www.google.com. That is you are typing like this. http:// Here this is a hypertext transfer protocol. And then the HTTP available with the port number 80. 80, which means that when you use HTTP protocol with the application, then it gets port number 80. And then it defined that whenever HTTP used, then port number 80 will be used. That means whenever HTTP is used, that means port number also will be used. And then similarly with other protocols such as SMTP, IMAP are the well-known port number are defined. That means, for example, the protocols here SMTP. How can you define the SMTP here? 25 with the TCP, which is providing the port number 25. The services IMAP. This is one of the protocol here. That means there are well-known port numbers defined with these services, and then remaining port numbers are used for the random application. Here some of the other protocols are also there. These protocol used for the that means in particular 0 to 1023 range. Here you are using for the random applications. Next important one, registered port numbers. The registered port numbers are in the range. This is a range 10242 495151. And then the registered port numbers are used for user processes. Yes, the registered port numbers are always used for the user processes. User defined processes are there. In the computer, user defined process. A process in the sense program under the execution. The user define the different services. In order to process these services, you will use this register port number. These processes rather than the common application have the well-known. That is this information regarding the port numbers. Coming to the next one, dynamic port numbers. Here, what is the dynamic port number? The dynamic port number is a range here, and then the name of the dynamic port number is a ephemeral port number. And then, for example, this what is the main purpose of this port number here? These port numbers are used to assigned to the client application dynamically when the client creates a connection. If the client wants to create a connection with the server, how can you create the connection here? Here you will create in a connection with the server by using TCP. Here TCP or either UDP also. That means the client establishing the connection. After that, the client terminating the connection by using TCP protocol. That means these port numbers are assigned to the client application dynamically when the client creates a connection. If the client creates a connection, then it's automatically assigned port numbers. And then the dynamic port numbers is identified when the client initiates the connection. Whereas the client knows the well-known port prior to the connection. And then this port is not known to the client when the client connects to the service. Here following are the common user port number for reference. Here these are all different port numbers here. Here these are all are the different port numbers used for the different purposes. For example, port number 7. What is the service? Echo service. That means the port just echo whatever is sent to it. That means, for example, hello. If you send the hello, automatically it's a reply as a hello. That is called here echo. That means this fuse can be used in many attacks, such as a fragile attacks, like that. Many attacks you are using. Here, what is the protocol for this port number? That means this port number used by the either TCP protocol or UDP protocol. Coming to the port number 20 or 21. Here, what is the service here? The file transfer protocol service. Here, the port used by the FTP protocol to send a data to the client. That means this transport protocol, that means this protocol applicable with the transport FTP with TCP. That means it will work with FTP with TCP. And then 22, secure shell, SSH. That means what is the use of this SSH? Used to secure the replacement protocol for the telnet. That means sometimes you are using the in the Linux programming, you are using SSH. That means it works with TCP as well as the UDP. And then the port number 23 telnet. The port number used by the telnet to remotely connect to the workstation or services. That means so many times you are using this port number here. That means telnet connection. You are in order to establishing the telnet connection. That means remotely connect to the any server. Connecting with the server, you are using this 23. That is a transport layer protocol. The transport layer protocol is in this case TCP. And then 25, simple mail transfer protocol service. Here, what is the service here? Simple mail transfer protocol used to send an email over the internet. For this, that means if you want to send the email over the internet, how can you send the email over the internet? By using SMTP. Here, it is a works with the TCP. That means that port number here is for this service 25. This is a well-known port numbers. These are all are. And then 53, domain name system. Here, what is the domain name system here? Here, the domain names, the main purpose of DNS service or DNS service is, or DNS server here is a converting the domain names into IP addresses. Here, for converting the different domain names into IP addresses, you are using the DNS service. Here, it is a 53 for DNS service. Port for the DNS request. The network routing and zone transfer. The TCP and UDP are the transport protocols. And then 67, dynamic host configuration protocol. That means you have a different addresses are there. Static addresses, dynamic addresses are there. The dynamic addresses assigned by the static address in the sense fixed that cannot be changed. Here dynamic address assigned by the DHCP. Here the 67 or 68 used on the network that do not use the static IP address assignment. The static address assignment, then you use a UDP protocol. 80. Hypertext transfer protocol, HTTP. What is the main purpose of HTTP here? That means this particular HTTP used for browsing the web pages on the browser. That means for browsing the web pages by using this HTTP protocol. 110 post office protocol. Here this port number used to retrieve the complete contents of a server mailbox. These are all different protocols and their services. And then for example HTTP port number 80. HTTP used in a World Wide Web. If your browser requests an HTTP page, it sends that the request to the port number 80. That means the port number 80 always works with the HTTP. That means this particular HTTP used in a World Wide Web. If your browser requests an HTTP page, that it usually sends a request to the port number 80. The web server is listening to that port, and this one reply to port. That is the port number, different port numbers available in a HTTP. And then for example, if you send the HTTP message to different port, one of the following happening here. If you send a HTTP message to different port numbers, then it's happening something. What are the happening here? The first happening here is a nothing to listen to that port, and mission replies the REST packet. The next thing here is a nothing to listen to that port. That means what is the thing here? 80 port. If you send the 80 port, nothing to listening to that port. But the firewall allows the request hang instead of reply. And then coming to the next third information here is a client has decided that trying to send a message to that port is bad idea and refuses to do it. The messages arrive at port that is expecting something other than the HTTP messages. Here, these are all some of the information. That means the HTTP secure is an extension of HTTP. HTTPS is an extension of HTTP. What is the information here? This is used for the communication over the computer network and also used on a network. Here, for example, it runs on a port number 443. So these are two URLs are equivalent. Why it is equivalent here? For example, http://www.example.com is a one address or one domain name. For example, http://www.example.com colon w443. Here both two are the equivalent. Why? Because it's a run on the port number 443. And then some of the other port numbers are there. The 880 for the HTTP, 8080 for the HTTP, HTTP for testing servers, and then 443 for the HTTPS, 22 for the SSH secure shell, 23 for the telnet, and then 25 for the SMTP outbound email, and then 110 for the POP3 inbound email, and then 220. All these services are in a FAT application layer protocol. That means all applications are in fact all are in a application layer protocols. That is a some information for references. See this one. Okay, ma. Thank you.
Okay, good morning. In the previous session, you completed the task sensor types, internet communication, IP address, MAC address, TCP and UDP ports for the IoT. For the IoT devices, you are using these number of information. Here now you are going to know about the application layer protocols for communicating from one device to another device. That means for sending a data or messages from one device to another device, the very important parts are here is in the IoT device application layer. Here one of the layer, link layer, network layer, transport layer, and then one of the important layer in a IoT system, application layer. The application layer protocols defines how application interface with the lower level protocol to send over the network. That means the different application layer protocols are there: HTTP, HTTPS, SMTP, COAP, WebSocket. That means MQTT, XMPP, DNS, and then AMQP. These are all different application layer protocol you are using in a IoT system. Here, any IoT system, that means these number of protocols you are using. And then coming to the first important one, HTTP protocol. The HTTP protocol is a application layer protocol for transmitting the hypermedia documentations. For example, hypermedia documentations like a HTML documentation. In the HTML page, each and every a component you call it as a element, or these elements are called as a tags. For example, there is a para tag, there is a hypermedia tag, there is a different tags available. That means each and every in the page you will identify the each and everything you will consider as a element. That means how to identify the element by using inspecting methods. With the help of inspecting, you will identify in the element related information. That is a hypermedia document. That means hypermedia documentations. HTML, for example, video files, you may document the, you may transmitting the audio files, you may transmitting the text files. That means any number of elements transmitting by using this HTTP. And then it was designed for communication between a web browser and then web server. The web browser in the sense client, web server in the sense simply called as a server, but it can be used for the other purposes also. That means for communication between a web browser and then web server, you are using this type of protocol, HTTP, hypertext transfer protocol. And then, for example, the HTTP follows the classic client to server model. Already explained that one. There is a client is there, there is a server is there. The client here in the right side diagram shows that the client always sending a request, the corresponding request, the server processes the request and then prepares an acknowledgement and then prepares a a response and then and send a response to the client. That is a thing. That means the HTTP always follows the classic client to server model, which with the client open the connection to make the request and then wait until receive the response. That means always client. What is the necessity of client in this case? It's a making the request and then waiting for the response. That is a simple information. Here there is a client system, the client system sending a request, server system process the request and then prepares the acknowledgement, prepares a response and then send a response. And then coming to the HTTP is a stateless protocol. That means every request you consider as a new request. That is a stateless. That means that meaningless. The server does not keep any data between a two requests. For example, first I am sending some request. I am entering the username and password. That is the one request. After that, if I want to send again another request, the server considers the second request as a new request. That means the server does not keep any data between the two requests. That's why that means any data state. That's why HTTP is a stateless protocol. The server does not keep any data between a two requests. Every request it will consider as a new request. That is a stateless protocol. In the some characteristics of the HTTP. What are the characteristics here? It is a protocol that allows a web server and a web browser to exchange data over the web. It is a protocol here. That means for allowing the web server and browser is simply called as a, remember that's a client. It allows a some communication for exchanging the data. Server sends some data, process the data. Again client sends you some data. You are exchanging the data. It is a request response protocol. Why it is a request response protocol? The client sends a request, server prepares the process the request, prepares a response, and then again sends a response. That's why this HTTP is a request response protocol. It works with the TCP, and then it uses a reliable TCP connection by default on the TCP port 80. Here it uses a reliable connection, TCP connection. Here it's not a, that means it's not directly not having any connection, but here it uses a TCP connection. And then already discussed that one. The HTTP is a stateless protocol. The meaning that each request here considered as a new request. And then in other words, server does not recognize the user by default. That is a simple information. That means that it is a stateless protocol. That means every request from the client you are considered as a new request. The server does not keep, does not get any information. Keep the any information. That is a simple information. Features of HTTP. That means coming to the previously discussed the characteristics, the features are there. HTTP is a media independent protocol. What is the media independent protocol here? That means any type of media content can be sent by the HTTP. The media independent in the sense it's not irrespective of any type of media, either audio files or video files, any type of audio files, any type of video files, a movie files or video files, any type of files can be, that means can be sent by the HTTP. Here, as long as both server and client handles the data content, as long as the both sides, that's why it is a, the important feature here is a HTTP is a media independent. Coming to the next important one, it is a connectionless. Why it is connectionless here? Why? Because it uses a TCP connection. That means works with the TCP 80 80 port number. It is a connectionless approach in which HTTP client, that means browser, initiate the HTTP request. After the request is sent to the client, disconnected from the server and wait for the response. Here was simple thing here. First, initiate the connection client. After initiating, automatically disconnecting the request. That means connection from the server. Automatically disconnecting that means connection oriented in the sense establishing the connection after sending the all request, terminating the connection. But here the client sending the request automatically terminate the connection. That's why it is a connectionless protocol. I think connectionless protocol in the sense client sends a request, terminate the connection, not waiting for the response from the server. Here, after request is sent to the client, disconnect from the server and wait for the response. That's why it is a connectionless protocol. Another feature here is it is a stateless protocol. Already you know, client and servers are aware of each other during the current request only. That means every time it sends a new request. That means the server every request consider as a new request. Here does not keep any data of the request. That is a very important thing. That is a stateless protocol. And then coming to the another important one, afterwards both of them forget each other. That means after completion of request and response information, both forget everything. That means I'm not sending request, I'm not getting response. But means it's a removing some kind of information. That's why it is a stateless. And then the basic architecture of HTTP protocol. Here, if you see the architecture of the protocol, the architecture consists of web client, web server, server side script, and then database. That means you will having the server side script. You will use any kind of scripting language, and then for storing that information, database, temporary storage. Here, the diagram represents a basic architecture of web application and that represent HTTP stands. And then HTTP protocol is a request response protocol. It is a sending request, taking the response. Sending request, taking the response. That's why it is a request or response protocol based on a client server based architecture. There is a client is there is a server is there. Server always sending the responses, client sending the requests. That's a based on a client server information. What is a client? The client is a simply our software information. Client is a software. That means if you installing the client software in your system, that's called here client. If you install the server software in your system, you represent it as a software. And then web browser, robots, search engines are like a HTTP clients. That means a very web browser, for example, Mozilla browser, Firefox browser, Internet Explorer browser. These are all are the HTTP clients. And then here in this case, web server act as a server. Any server act as a server. And then what is a client? What is a client here? Client always sends a request to the server. Here, how can you send those requests to the server here? In the form of request method, URI, protocol version, followed by MIME. That means MIME in the sense like a message containing the request modifiers, client information, the possible body content over the TCP connection. That is a simple client, always sending the request. And then server. The server responds with the status line, including the message protocol version, success or error code, followed by the MIME like a message containing server information. entity metadata, and then possible entity body content. This is a information regarding the server. Here, always sending the respond with the status line. The status line includes a message protocol version, success or error code. That means the process success or error code, and then some of the other information. And then what is the purpose of the HTTP protocol here? What is the main purpose here? The main purpose of this protocol here is a retrieval of data from the website by using internet. It works on a top of the TCP IP suite protocols. Here always top here application layer protocols always top. Here application layer that is a simple information, and then the working of the HTTP protocol. HTTP uses a client to server model where the web browser is a client that communicate with the web server hosting the website. Here, that means with the client is a browser, it's communicating with the web server and then hosting the website. Whenever clients request us some information, say click on a link, hyperlink to the website or server. The browser sends a request to the message to the HTTP server for the request object. Is it clear or not? If you want to, there is a hyperlink is there. If you click that link, the link send a request message to the HTTP server for the requested object. Then HTTP opens the connection between a client and a server by using TCP. HTTP sends a request to the server. After that, which collects the requested data. After that, terminate the connection. That means it's not maintaining the continuous connection just like a TCP. HTTP sends a response with the object back to the client. HTTP closes the connection. This is the working of the HTTP principle. Here, the HTTP connections may be two types of connections are there. Non-persistent HTTP connection. Other one is a persistent HTTP connection. Here, what is a non-persistent HTTP connection? Persistent HTTP connection. That means basic information regarding the non-persistent HTTP connection. Here, non-persistent HTTP connection is a one that is used for serving the exactly one request and sending the one response. See here, that means it is taking one request after that sending one response. But here, the persistent HTTP connection takes a multiple request. Multiple requests. Here, HTTP connection is a one that can be used for serving the multiple requests. Here, non-persistent one only sending one request. HTTP is a server. That means HTTP server closes the TCP connection automatically after sending the HTTP response. That's a non-persistent. Here, persistent. What is the persistent? HTTP server closes the TCP connection only when it is not used for the certain configured amount of time. Here, if not use the certain amount of time, then it closes the connection. But here in the non-persistent, automatically close the connection. In the persistent, whenever when it is not used for the certain amount of time, it's not used for a certain amount of time, then only it will close the connection. And then new separate TCP connection used for each and every object. See here, the client send request, after that close the connection. It's not waiting for the response. New separate for each and every object, you are going to opening the new connection. The persistent, coming to the persistent, single TCP connection used for sending a multiple object one after another. Here, for example, HTTP 1.0 supports a non-persistent connection by default. HTTP 1.1 supports persistent connections by default. That is a simple information. If you need any references, this is a reference information. Here, coming to the next important one, HTTPS, Hypertext Transfer Protocol. Here, the secure protocol. What is the difference between the? It is a extension one. It is a secured one. Sometimes you need to send a data in a secured mode. Then particular cases you are using HTTP. Yes, HTTP is a extension of HTTP. It is used to secure the communication over the computer network and is used on the internet. That means secured communication. Authentication is required. That means if you want to send a data, the server maintain a certification, server maintain a licensing, the client also maintaining the licensing. That means you require some private key. That means why? Because you have to send a data in secured mode. That's why you require all these information. That is why it is called here secured one. Here, coming to the HTTPS, the communication protocol is encrypted. That's why it is a encrypted HTTP using transport layer security. That means for previously called as a secure socket layer. The protocol is also referred as a HTTP over the transport layer security or HTTP over the secure socket layer. And then what are the requirement for the HTTPS? When you browse, you normally send a and receive the information or normally send a data by using HTTP protocol. I think you know very well. That means if you want to browsing www.google.com, it sends a request by using TCP protocol. That means by using HTTP protocol. What is the HTTP protocol? Here, send and receive the data using the HTTP protocol. Many times you need exchange the sensitive data. Sensitive data means that means that data cannot see the unauthorized person. That means that data will see the authorized person only. That's why you have to do some secured information. That means which needs to be a secured and to prevent the unauthorized access. And then, for example, of the some of the scenarios, banking websites, payment gateways. That means it is a very secured one. Shopping websites, all login pages, Gmail pages. That's also a secured one. Emails, email apps. That means these are all secured one. In particular cases, HTTP, yes, you are using. That means this HTTP, yes, are required. That means the public key certificates are required for the server in the HTTP protocol. For example, client request for the HTTPS page. For example, HTTPS gmail.com, www.gmail.com. Why? Because that is a web page, that is a secured one. When using the HTTP connection, the server responds to the initial connection by offering a list of encryption methods the web server supports. Here, in response, the client select the connection method, and client and server exchange a certificate to authenticate their identities. That means there is an identity. For example, client has the identity. So identity in the sense, for example, for example, your roll number. Client has the one roll number. Server has the one roll number. Here, the client showing the roll number of to the server. That is called here client and server exchange certificate to the authenticate. Here, after this is done, both web server and client exchange the encrypted information after ensuring that both are using the same key and the connection is closed. That is a simple information about the HTTP. Yes, for hosting HTTP yes connection, the server must having the already discussed that concept public key certificate, which embeds the key information with the verification key of the owner identity. Here, almost all certificates are verified by the third party, so that the client assured that the key is always secure. That means what is the case here? You required certificates for the server. Then only you will send the. That means you have to verify by that information third party. HTTP you begin with the HTTPS and use the protocol 443 by default. Whereas HTTP, what are the difference here? HTTP you just say begin with HTTP :// colon 80. That means by default 80. It is a HTTP. By default, it is a HTTP. HTTP is not encrypted, but HTTPS is designed for the encryption purpose. Here, withstand such as attacks is considered as a secure against them. And then coming to the to prepare the web server to accept the HTTPS connection. Administrator must create a public key certificate for the web server. This certificate must be signed by the trusted certificate authority. That means for the web browser to accept without warning. That means that's certified by the authority, and then the authority certifies that the certificate holder is operator of the web server that presents it. The web browser are generally distributed with the list of signing certificates of the major certificate authority, so that they can verify the certificates signed by them. That is a simple information for referencing this one. You have a different references are there. You are coming to the constrained application protocol. What is the need of constrained application protocol? This is a specialized internet application protocol, the constrained devices. For example, IoT devices, you are using this protocol. Here, this is defined in a RFC 7252. Here, it enables to communicate over the internet always. The constrained application protocol is a specialized internet application protocol. Here, this application protocol especially target for the constrained hardware, such as a 8-bit microcontroller, low power. That means in the system, in the IoT device, you are using the different controller and interfaces. Here, 8-bit microcontroller and then similar devices that cannot run the HTTP or TLS. That is a thing. That's why you are using the this type of protocol. Any devices not work on the HTTP, then you use a constrained application protocol. Coming to the another important protocol here is a WebSocket protocol. The WebSocket protocol is enables the two-way communication between the client and remote host. The remote host in the sense server. It is establishing the two-way communication between the client and server. The client running a untrusted code in a control environment to the server, and then the server that has a opted into the communication from that code. The security model used for this code is a origin-based security model commonly used by the web browser. That is a WebSocket communication. That means most of the times the WebSocket, for example, if you comes to the level 1, level 2, level 3, in any case of IoT template, you are using the WebSocket protocol. That means this particular WebSocket protocol establishing the communication takes the data from the devices and then transferring the data into application. For transferring the data into application, you are using the WebSocket protocol. Other important one is a mission to mission Internet of Things. Mission to mission, that means mission to mission Internet of Things connectivity protocol. Here, what is the Internet of Things connectivity protocol here? It is designed as a extremely lightweight push publish subscribe messaging transport. You know very well about the published subscribe model. Publisher always publishing their documentation. Here in the documentation, the broker is there. The broker maintains the broker, you are maintaining the publisher always subscribing. And then just like I already explained the concept by using YouTube. That means I am the publisher. I am always posting the some of the videos. But subscriber is there. Subscriber in the, for example, student is a subscriber. Student always subscribing the some information. When I am posting the any video, that automatically send to that information to the subscriber. That is a publish, subscribe, messaging, transport. That means useful for connection with the remote location, whereas a small code footprint is required and network bandwidth is at a premium. That is a MQTT. The next important one is a extensible messaging and presence protocol. What is a XMPP? Here XMPP is a communication protocol for the message oriented middleware based on a XML. It is a XML in the sense already you know. HTML is a hypertext markup language. XML in the sense extensible markup language. You are creating your own tags in XML. Here it enables the near real time ex, ex, exchange, the structured yet extensible data between any two or more network entities. That is a purpose of XMPP. Coming to the already you know very well about the DDS. DDS is a middleware protocol and API standard for the data centric connectivity from the object management group. It is a simple protocol here, DDS, the data distribution service. Here this it is a middleware protocol and API standard for data centric connectivity from the object management group. It integrates the connects of the system together and provides a low latency data connectivity. Extremely it is a reliable. That means reliable in the sense you can believe this protocol here. It is a secured one. It is a safety protocol. And then scalable. You can extend to any, that means scaling up, scaling down. That means horizontal scaling, vertical scaling. Here, the scalable architecture that business or mission critical Internet of Things application needed. That's why we are using the DDS protocol. Coming to the another important one is the AMQP. AMQP IoT protocol consists of uh, the AMTP. What is an AMTP in this case? AMTP is a IoT protocol, consists of hard and fast component that route and saves the messages within a broker carrier with a set of policies for the wiring the component together. AMQP is a protocol enables the some programs to talk to the dealer and engage with the AMQP model. These are all different protocols. Okay, thank you, Ma.